In this lecture, let's take a look at providers in more detail. We saw in the previous lecture that after we write a Terraform configuration file, the first thing to do is to initialize the directory with the Terraform init command. When we run Terraform init within a directory containing the configuration files, Terraform downloads and installs plugins for the providers used within the configuration. These can be plugins for cloud providers such as AWS, GCP, Azure, or something as simple as the local provider that we use to create a local file type resource. Terraform uses a plugin-based architecture to work with hundreds of such infrastructure platforms. Terraform providers are distributed by Hashicorp and are publicly available in the Terraform registry at the URL registry.terraform.io. There are three tiers of providers. The first one is the official provider. These are owned and maintained by Hashicorp and include the major cloud providers such as AWS, GCP, and Azure. The local provider that we have used so far is also an official provider. The second type of provider is a partner provider. A partner provider is owned and maintained by a third-party technology company that has gone through a partner provider process with Hashicorp. Some of the examples are the big IP provider from FI Networks, Heroku, DigitalOcean, etc. And finally, we have the community providers that are published and maintained by individual contributors of the Hashicorp community. The Terraform init command, when run, shows the version of the plugin that is being installed. In this case, we can see that the plugin name Hashicorp/local with the version 2.0.0 has been installed in the directory. The Terraform init is a safe command, and it can be run as many times as needed without impacting the actual infrastructure that is deployed. The plugins are downloaded into a hidden directory called .terraform/plugins in the working directory containing the configuration files. In our example, the working directory is /root/terraform-local-file. The plugin name that you see here, Hashicorp/local, is also known as the source address. This is an identifier that is used by Terraform to locate and download the plugin from the registry. Let's take a closer look at the format of the name. The first part of the name, which in this case is Hashicorp, is the organizational namespace. This is followed by the type, which is the name of the provider, such as local. Other examples of providers are AWS, Azure RM, Google, Random, etc. The plugin name can also optionally have a hostname in front. The hostname is the name of the registry where the plugin is located. If omitted, it defaults to registry.terraform.io, which is Hashicorp's public registry. Given the fact that the local provider is stored in the public Terraform registry within the Hashicorp namespace, the source address for it can be represented as registry.terraform.io/hashicorp/local, or simply by Hashicorp/local by omitting the hostname. By default, Terraform installs the latest version of the provider. Provider plugins, especially the official ones, are constantly updated with newer versions. This is done to bring in new functionality or to add in bug fixes. And these can introduce breaking changes to your code. We can lock down our configuration files to make use of a specific provider version as well. We will see how to do that later in this course. Now, let's take a look at the configuration directory and the file naming conventions used in Terraform. So far, we have been working with a single configuration file called local.tf, and this is within the directory called terraform-local-file, which is our configuration directory. This directory is not limited to one configuration file. We can create another configuration file like this. The cat.tf is another configuration file that makes use of the same local_file resource. When applied, it will create a new file called cat.txt. Terraform will consider any file with the .tf extension within the configuration directory. Another common practice is to have one single configuration file that contains all the resource blocks required to provision the infrastructure. A single configuration file can have as many number of configuration blocks that you need. A common naming convention used for such a configuration file is to call it the main.tf. There are other configuration files that can be created within the directory, such as the variables.tf, outputs.tf, and providers.tf. We will talk more about these files in the later sections of this course.